Hi, I'm Roberto Marquez. In this video, I demonstrate a command line application. The main feature of the application is that it watches the file system for changes, and if any changes are detected, it executes a command. The software prerequisites for the application are an operating system with Java 8 or better. There are a couple of use cases for this application, and they're documented here on this GitHub repository under my account, and the project name is Software Development Tools. And this is the full path to where the user stories are defined. And the original reason I wrote this program is the first user story, and that is, as a test-driven developer, I need a tool to watch source code files so that unit tests are run when production code changes. And like I said, that was mainly what I wrote it for, but this next one is for a developer that needs to watch um, the file system in this manner, that as a disk quota constrained developer, I need a tool to watch files under a file system directory so that an alert is produced if the file size limit is reached. And then I thought the application could probably be used by someone who's writing documentation, and that's this last one, that as a content writer, I need a tool to watch document files so that I'm alerted when a word count limit is reached. And I'll demonstrate these user stories next. So next I'll demonstrate the user stories, the first one being for unit tests. And it's a Java application. So we're going to use Java to invoke the main application that's in the jar. And there's this Java watcher shell script that stores the command. And here it is in this file. In this file. And you can see that the path is already specified, and that the config file is also specified as watcher.properties. So what's in watcher.properties? The configuration. And it specifies a pattern of star.java because we want to execute unit tests when Java changes are made. And the command to execute is maven clean test. And the quiet period is specified as 30 seconds. So if we run this application, you'll see that there are a couple of startup messages, and nothing actually happens until you change file. So let's do that. And we should see everything pass because this project is in a good state. So here's one of the Java production code files, and let's just make a silly change like adding another ellipsis. And we should see processing in the background. And the last thing it should do is run that maven clean command, and we should see the build execute. And you see here that 7 tests were run with 0 failures and no errors, and the build was a success. So that's all well and good, but let's see what it would look like if it fails. And I'm just going to introduce a false positive here and say, instead of expecting star.jpg, I'm going to fudge it up with a bunch of G's. And on its own, it should detect there was a change, and it's going to run the maven command again, but this time we're expecting it to fail, which it did. Still the same number of tests, but now we have 2 failures. And that helps me out to, I'll have that application running on like a separate screen, and it just runs the test whenever I make a change. So that was a simple one-liner. The next two will be a little more complicated in that they use a shell script. And the first one will be file size test, demo, and that has its own folder and its own input that is defined here. Oops. And it also has a watcher shell script. And this one's a little bit neater in that I have it on. Oops, let's correct this real quick so that all the tests are correctly running. And while it's doing that, I'll show that what this script looks like. It's using the same jar file, and specifying this properties file, which is here, and it executes the shell script file size.sh, and the pattern that it's working on is star.data, and the quiet period is configured to be 30 seconds again. So what is in file size.sh? It is a one-liner, but it's a little more complex than just a single command in that we are finding all data files and specifying the size that we're looking for that's just greater than 10 bytes. And if we find something, we're going to print the name of the file is over. And then that is piped to xargs echo, which is then piped to Fiesta, which will read out which files are over. So let's run that. I'm going to stop the original one for the unit test and change directory into I just want you to see what I'm doing, into the demos and the file size demo. Okay, so to call it, it'll be watcher.sh, and I'm going to turn up the volume so you can hear what it's going to do. So if I change the input for a file that's under, it should just, we shouldn't hear that anything is over.
Input slash super large data is over.
Oh, I'm sorry. There is one already that's over. So let's correct that. So what was it again? Super large. I just want to hear it real quick. Oh, the wait time has to expire, which is 30 seconds. But I think it said something about over. Okay, so this one's under super large data. Here it is. Okay, so it's talking about this one. Remember, the limit is 10 bytes, so if I bring it down to 1, yeah, so nothing is over, but if we add that data back, it'll pick up that the file limit has been reached. But we gotta wait the 30-second quiet period. I guess we could set that to 10 seconds so we're not waiting so much. Maybe I can trigger it with
input slash super large data is over.
Okay, so do I really have that? I'm going to change the properties instead of 30 to 10. Okay, this time we'll run it again and expect a quicker turnaround. Okay, so now nothing should be over. And it should only wait 10 seconds. Don't make me a liar. Oh, I'm sorry. If there is nothing, yeah, let's look at what the script is doing. It's only going to print it if it's over. So we took away the big data. So if I add it to this one, the one that's normally under, it should work now.
Input slash under data is over.
Okay, it's actually working as expected. So I'll move on to the third. Okay, for the third demonstration, it will be on the word count user story. And for this one, it has prerequisites for the demo, not the actual application. And what they're the Linux packages Festival for text-to-speech and SOX for playing audio files. And I'll also be in the NetBeans IDE to demonstrate this. So first things first is to change directory into that demo's directory. And it's not file size, but word count. And in that directory, we have a very similar shell script called watcher.sh and a properties file that configures that. And here's watcher specifying the properties file, which is here, and it will execute wordcount.sh when star.txt changes are detected, and the wait period is configured for 10 seconds. What does word count do? It populates the word count file by finding all text files, and then it counts the words in those files using xargs and wc, and then uses sed to remove that last line, which is the total words in the whole file, and then it writes it out to disk. And that output file is processed by an awk script called report.awk. And this isn't an awk video, but I just want to go over what the awk script is doing. And for every line report, it checks if the word count is greater than 10, and that's just an arbitrary limit that I picked, 10 words. Then it'll print that it's over, and it'll play a file called womp. And conversely, if it is under, it'll print that it's good and play a sound called poing, boing, that indicates that everything is good for that file. Alright, so let's look at some data that is in the input file, which is, we'll start off with a file that's under it. It only has 3 words. Oh, whoops, I guess we should start the application. Okay, and once the application is started, if we make any changes to the .txt files, it should pick it up. So there is so that noise means that that first noise indicates that it found at least one file that's good, and that second noise means that it found at least one file that's bad. And one that's bad is this double letter text file. And you can see it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So if we take off the 10th file, we should only hear one sound that indicates that all files are under. And I think it's just waiting for the quiet period to elapse. Okay, so right there it detected there's only files that are under the word count. And if I put that text back, right, so that there are 11, 12, 13, 14 words instead of 10, then it'll pick that up and play one sound for the songs that are under and one time for the files that are over. So that's the good one. And the womp womp is for that one that's out. And that pretty much concludes the demos for this application. I hope you like the demonstrations of the Filesystem command line tool. Like and subscribe for more command line content.